Good morning, I'm Terje. Today I will show you how you can create an assembly FEM of a bolted hinge on a traffic mast. You will learn how to create the assembly FEM based on individual finite element models that you map to the assembly FEM. I will show you some bolt modeling, two types of bolts, with and without nuts. I will show you free and swept solid meshing and the application of RB2 elements where you want to put loads. This is the first of two videos. The last video will show you how you can define contact surfaces, loads, boundary conditions, and bolt pretension. So stay tuned. This is the assembly model of the bolted hinge. And it's an assembly of these two yellow extruded girders. They are extruded in aluminum. These are just two sections, not a complete girder, because the component of interest here is the blue connector or hinge. And this one is made of steel, as well as the green one. It's also a steel construction. You can see that all parts are bolted together. The horizontal girder is bolted to the connector with 6 bolts. I think it's 6 M16 bolts, and it's the same here. If we hide the connector, you can see that the same bolts, same 6 bolts, are used to connect the top plate with the vertical girder. And then we have 4 M20 bolts, which connects the top plate to the, let's have a look at it, to the connector. So this is the assembly. If you want to create a finite element model of an assembly like this, you can do it 2 different ways. I will first show you a quick and dirty way, and then the best practice way, which is to create an assembly FEM. So here we have the assembly, which is my working part, and now I can go to create new component, and I can give it a name. Let's call it hinge bolted. Okay. Then I make my new part, which I call hinge bolted, as the work part. And then my next step is to go to the wave geometry linker command, and the filter is set to bodies or solid bodies. And then I select the 2 girders, the top plate and the connector. And I keep the associative option on. Then I make my hinge bolted as my displayed part. And here you see how it looks. You can see that I've copied the solid bodies from the individual part files into a new file, and now I can use this new file to create a new FEM model and a simulation file, which is a really straightforward and easy process. Then I will show you the best practice way to create a mesh of an assembly like this. What I have to do then is to mesh first all the individual parts. And in this example, I don't want to mesh every part. Therefore, I will deactivate the bolts, which I will mesh on the assembly level as bolt FEM models or bolt elements. Then I start with the connector, the central part, and I can make it the displayed part like this. I go to application pre and post, and I create a new FEM. And it's called connector FEM. That's fine. I don't want to create an idealized part file, so I skip that one. And here we are. First, I want to apply material, and this connector is made of steel, so I apply steel material. Then I use a free mesh, use Tetra 10 elements, element size 10 millimeters is fine. and I choose not to include all small features. So I drag this model cleanup option to the left. And I will automatically fix failed elements. So I switch that one on. Okay. So this is my mesh. 2 elements over the thickness, which is best practice as well. Then I go back to the part file, which allow me to go back to the modeling application. And I move back to the parent assembly, hinge assembly. And then I want to mesh the top plate, the green one. And I make it the displayed part. And this one is also a steel part. I go to the pre and post application, same procedure, and new FEM, and accept the default name, that's okay. Same options, no idealized part, this is a clean geometry. Then I go to, well, let's first apply the material, assign material, steel as well. Where is steel? There it is. Okay. Then I mesh it with the TET mesh, same mesh as the other part, same options, automatically fix failed elements, element size 10 millimeters. Okay. There it is. Looks good. Then I go back to the geometry part file, and then I can go to the modeling application, and I go back to the top level, the assembly level, and then I want to mesh the 2 girders, and the 2 girder instances here are represented by just one part. So if I do select make display part, I'll get this one on the display, which is copied to 2 instances in the assembly. Then I go to the application again, pre and post. I want to create a new FEM, accept the default name, the same options, and there we are. Again, apply the material, assign material, and this one is made of aluminum, so let's choose A356. So, okay. I don't want to use a free mesh on this one because it's an extruded part, and then I can always use a 3D swept mesh. I can use the same element size, 10 millimeters, and to make the simulation fast I just used C-hexa 8 elements. Should have used 10, I guess, but... So now I use multi-body infrared target. That means I can select this face, and NX will find the path through the model to the other side and find a corresponding face. And then I press apply or OK, and then I have a hex mesh or a swept mesh. There are some small instances here or features which I could have removed, but I'll just let them be there. Okay, then I go back to the assembly. I go up to the modeling task and go to the top level hinge assembly. Now I've meshed all the individual parts and I'm ready to create the assembly FEM. So now I select the hinge assembly as the active part, and then I go to application, pre and post, and I right click on the hinge assembly, and this time I won't create a new FEM, but I will create a new assembly FEM. And I accept the default name, okay. And no, nothing pops up on the display. That's because I have no geometry. I have to map the geometry or the meshes to the assembly definition here. So you can see the instances, girder, all the bolts which are not included. I could delete them, but let's first select the girder. And then I use map existing because I have a FEM file which I can map. And then I choose girder FEM 1, accept. So here I have my first mesh. Then I will map existing file for the other girder, the same part but two different instances, and that's why this mesh will apply or appear in a different position. Then I go for the connector, map existing, and I use the connector FEM. Okay, there we are. Then my last one, which is the top part, and then I map existing on that one too, and here we have the top part. Okay, so here you see I have created my assembly FEM. I might want to change the view or the color of the different FEMs here, so I go to the meshes, right click, edit display, and I can choose orange on this one, like for the geometry. I do the same with the other girder part or mesh, edit display, choose orange. Then it's easier to see that this assembly FEM is actually an assembly of component FEMs. That's the girders, and then I go to a connector, and I believe that one was blue on my geometry, so let's keep the same color on the mesh and the geometry. I would say that's best practice. And then cornflower, I like that color. Okay, and then it's just the top plate. It has a different color already, but let's select edit display, strong C. Let's see what we got. Emerald. That's a fine green color. So there we are. Now I've created the individual finite element models for each part or instance and mapped those meshes to the different geometries in the assembly. And now I have an assembly FEM. The next thing I will do is to add the bolts or the bolt models which will connect the different FEMs. First, I will create some M16 bolts, and I will start with this blue connector, and I will attach it with 6 bolts to the girder, the horizontal girder. Then I go to the bolt connection menu or command, and then I use bolt in tapped hold. You have two options, bolt with nut and bolt with tapped hold. Then I select the edge, and I select this edge, and you can see I've created an edge on my model which matches the washer size. Then that will be the position of the head, and then I select the surface, and perhaps I should have removed the mesh so we could see which surfaces I'm selecting, but I'm selecting 2 surfaces in this hole. And then I specify the bolt length, it's 150 millimeters, and the effective threaded length, which is 70 millimeters. And then as the shank element, I'll use a bar element. And I don't have to specify the orientation because I will use a rotational section or a rod section. And I don't want to use automatic creation. I will make a new collector, and I will call it 16, M16, give it a name, and I will use the type physical property type P bar, and I want to create a physical bar. So here we are, I call P bar M16. Then I specify the 4 section, and I'll use a rod with diameter 8 or radius 8 millimeter, gives me the 16 millimeter diameter. Okay, close. And I use steel as the bolt material. Then I've created the mesh collector, which defines my shank. And the spider connection, well, I'm not using a spider in the junction plane because I will define contact between the flanges. But I will use an RB2 element as the threaded connection. And then I press apply. And then I got the bar element here. Then I do the same here. I select this edge, that edge. I use two surfaces here to define the threaded area. I do the same with all bolts. I could actually have selected all nut edges at once. Apply. And then the last three. Apply. Let me see, something went wrong. C-bar. There it is. And then that last one. No, it wasn't the last one. I have one more left. Tapped surface. There we are. So now I've created 6 M16 bolts. However, you don't see the shank of these bolts, so I want to do a change to the display settings. I choose all these and I edit display, and here are two options that you should look at. Display section, I use solid and apply. Then you see here that my bolt shank has been visualized as a solid bar, and that's a check on the size of the bolt is okay, correct. So that's 6 of the bolts, but I also have to create bolts between the top plate and the vertical girder. So now I will remove the connector, and then I will select these. I could also switch off the mesh to make the display a bit nicer. I go back to my menu, bolted connection, and now, yeah, it's the same type of bolt, bolt in tapped hole. So I choose this edge, tapped surface. There are also 2 surfaces inside this hole, and the display settings is not solid for these bolts yet, so I have to go and change them after I created the bolts. So this is just a repetition of what I've already shown you. I select the top edge, the nut edge, and then I select the hole surfaces. Okay, 3 more bolts, and then we're fine. When you do work like this, it's really a benefit to have a space mouse to use to orient and zoom, panorate in the model. So those were the last M16 bolts, and I have to put on or specify the display option, solid for all. Okay. They are not visualized as solids yet. I have to check why. Edit display, solid, apply. Okay, there we are. No bolts, no all bolts are visualized as solids. And the next thing I want to do is to create the M16 bolts. Sorry, the next thing I will do is, of course, to create the M20 bolts. Then I go back. I'll need to visualize my connector and top plate, and I can switch off the display of the girders like this. And now I want to create another type of bolt. I will go for a bolt connection, and then not bolt in tapped hole but bolt with nut. And then define head by selected edge, and I go for this edge here, and then define nut by another edge, and that one is here. And then I select this edge because I haven't split the bottom surface, so I don't have an edge where the washer, which represents the washer size. Instead, I can use this option here, which is spider diameter percentage of hole, and I can increase it to 200. That will create a spider where the nut is, which is bigger than the hole and the same size as the nut. And then I need to define the shank element, and I don't do it there, I do it here. New collector, and then I call it for bar collector 20. And then I want to make a bar of type P bar. Create physical. P bar 20 is a proper name. And then I create a 4 section. And I create a new one. And the rod is okay, but I call it rod 20. And the diameter, or dimension 1, which is not the diameter but the radius, it's 10. Okay. Close. And then I will create a property with this rod section 20. And I want to specify steel as the material. Then I have the mesh collector 20 assigned to the bolts which I'm creating. So then I specify the RB2 as a spider in the bottom and top, and that's okay. And then we press apply. And then you see here that actually the spider will extend from the hole 200%. So it will represent roughly the washer size for the nut. So then I go to the next bolt. I select this line or edge, which has the same size as the washer, so that's okay. And then the same here, I select these two edges and I use a percentage of 200 and I press apply. That looks good. And then I go for this one, select this edge and the nut edge at the bottom, these two, apply. And then we have two more to model. We select this edge and the nut edge here. This modeling feature in Annex is really good. I like it. So there we have two bolts and we have two bolts here. 4 bolts, M20 bolts. Cancel. And the last thing I will do is to visualize those bolts. Okay, we have a lot of RB2 collectors which I could remove, but that's not so important. And then I added display on these, and I want to display the M20 bolts with a solid geometry. Then I want to relabel my assembly FEM, and I also want to display my girders. I right click on the assembly FEM model and I use this option called Assembly Label Manager. And as you can see here, there is a node numbering conflict between the individual FEMs that I map to my assembly FEM. And I can simply solve that by choosing this automatically resolve command. And then you see the labeling is approved. The very last thing I want to do is to go and create a 1D connection. Point to face is okay. And I want to make an RB2 because in the center of this horizontal girder I want to apply a force and a shear load. So I'll select the point and I can choose my point constructor. And I use between 2 points, and I could choose the center point there and the center point in the diagonal location, and that's okay. and then that will be my point. And I select my surface, and that's the complete end surface of the girder. So there I have my RB2 element. I could have applied torque or a moment and a shear force directly on the surface, but I might get some conflicts then with other constraints. So then my assembly FEM is ready. The next thing I have to do is to establish a sim file and create contacts between the different parts and bolt loads and constraints and the shear force, applied shear force and torque at the horizontal girder.